week at a glance sort of thing. What is our job today? What's our goal today?
Finish 10.2.
Finish 10.2 and start 10.3, which we will then finish on Thursday. So our goal is to be done with 10.1, 10.2, 10.3 by Thursday. Does that make sense? Our goal is to be done with 10.1, 10.2, 10.3 on Thursday. Then you can have the weekend to finish up that 10.3 homework. I know a few of you guys are playing catch up for different reasons, so if you need that 10.2, if you're like, I can do both this weekend, I mean, that's being very ambitious and yet at the same time. I am willing to give that to you, just let me know, and then we're going to be doing 10.4 on Monday, and that's our last section before spring break. I haven't fully decided what we're doing here, there, everywhere, but anyway, 10.4 is where I'm planning to stop chapter 10. And then next week our schedule is AB minimum day. Okay, I think that's pretty much all the logistics. Let's go ahead and pop back into 10.2. I know some of you might have WebAssign questions already, but let's go ahead and just kind of finish up this section first. Maybe we'll do a quick peek into WebAssign just for a little bit. Like I'll put a timer on, let you guys have a break / WebAssign checking in and seeing if you can find any problems. You're like, we did not go over that. And then we're going to go ahead and end today with starting on 10.3 that's already up in your Jamboard. That's just that if anybody heads over there early, that's not to take notes on. Notes start on the second slide, and that's where we'll start. Okay, here we go. I put this one up on the screen just because it's like some of you want every single formula possible to talk about a parabola. Here it is. This is every single possible orientation of a parabola. Up, down, right, left. And each of their corresponding foci, plural of focus, and each of their corresponding directrices, plural of directrix, and each of the little baby formulas. However, for someone like me, I'm like, oh, hey, if I know what way it's going, where's the focus always, every single time? Is anybody a pattern person like me? Where's the focus every time? In the mouth of the parabola, in the concavity, right? So if it's facing up, where's the focus going to be? Straight up. And I'm like, oh, cool, I'm adding p to the y value because it's changing the height. Or if it's down, I'm going to be doing what to the p value? Subtracting it from the y value. Although that looks like a plus. It would be a negative number, it ends up subtracting. If I'm going to the right, then my focus is going to be to the right, so I'm going to be adding the p to the h. Or if I'm going to the left, the focus is going to be to the left, so I'm subtracting the p from the h. I know it looks like adding, subtracting, the p is a negative number there. And then in my brain, I'm like, oh, hey, it's a horizontal line, because it's going to be outside the parabola. So y equals, but I'm taking away p, or y equals, I'm adding p, or x equals, I'm adding, or x equals, I'm subtracting. But that's my brain, so just because my brain likes patterns and it's like I'd rather memorize it with patterns, some of your brains are like, give me all the details. Okay, here are all the details. But let's go back here. And let's talk about what you had. What did you have as your clues? And did you graph them first like I hinted at yesterday?
Yes.
Your focus was at 2,2. So if your focus was at 2,2, you should have, if you were visualizing, put a focus there. Your directrix was at x equals -2. Did you guys go to the -2 tick mark and make it long? If you did not get that that was a vertical line, that would have totally thrown off your picture. You could have gotten a very wrong orientation, 2,2. What is the only possible way that a parabola could go with those two clues? To the right, because it needs to be eating the focus and it needs to be not intersecting the directrix. The only way that can happen is if I have a sideways parabola, and specifically since the focus was on this side, the directrix on that side, it had to be this one. Once again, some of you need these pictures. That's the only one that works. But for those of you that can visualize it in your head, once again, that's the only way that works. Andy?
So if it was like y equals -2, then it would be like going up.
Mm-hmm.
Okay.
Well, I guess -2 would have been down here. Yeah.
Okay.
Yeah, exactly. But since it was an x equals -2, it had to be the other way. So then coming back here, my brain just naturally sees it, but once again, not all of yours necessarily would. Do you know where the center would be? Or the vertex, I should say. Sorry, not center.
0, 2.
0, 2. Why? Because the center is always going to be halfway in between the focus and the directrix. You see it? So if it's 2 this way and that's 2 that way, the midpoint of -2 to 2 would be 0, and then it's going to be at the exact same height so that I can have that orientation. Now, how do I get an equation for this? Well, that's the next question, but does the orientation make sense? Okay. So then my advice yesterday was, once you get a picture with your clues, then think about the standard form you're going to use. So the standard form I would use, sorry, that was the clues. That was review. Here we go. If I'm talking about a sideways facing one, then I need the y to be squared. X squared is a normal guy. I know it's written abnormally. We talked about that yesterday, but even though it's written abnormally, still x squared is the normal parabola I'm used to. Y squared is going to be that sideways guy, so I'm going to use, don't worry, I'm writing it right here for anybody that hasn't gotten it yet, my bad. Y minus k squared equals 4p x minus h. And some just quick patterns that we saw yesterday are things like the h is still paired with the x, the k is still paired with the y. That's kind of old school as far as hk being the vertex. What's different is that we don't have like the squared guy on this side with an a. We've rearranged things to be able to get this key player isolated in a nice, pretty way where we can actually be talking about the focus and the directrix. So what'd you guys plug in? Who's my H and who's my K? Because we think of our HK as our vertex is 0, 2, so put the 0 in the X of the vertex, the H spot, put the 2 in the Y of the vertex, the K spot. How about my P? And someone describe to me or describe to the class, what is P again?
The distance between the focus and the vertex.
Yeah. Between the vertex and the focus. Now, is it mimicked on the other side with the directrix?
Yes.
Yes. But the directrix is technically -2 away, right? So for the P, yeah, the magnitude, right? The magnitude, the distance is still 2. But just thinking about whether it's a positive or whether it's a negative, this picture does go ahead and talk about it as well. P is positive because the focus is to the right, or P is negative because the focus is to the left. P is negative because the focus is down, or P is positive because the focus is up. That same idea of thinking about positivity. Where should we focus for the sign of P? On the focus. We should focus on the focus. Where is it at? It's to the right. Okay, it's a positive direction. Awesome. We'll go ahead and plug in a positive 2. What if this was facing left? -2. Does that make sense? So we take the distance, but then we also have this direction, like vectors, kind of a directed distance where it's not just 2 because it's 2 units. It's positive 2 because it's 2 units to the right to get to the focus.
So the focus would have had to been like -2 too?
In order for the P to be negative. Yeah. Yeah. Right.
How did you find the vertex again?
The vertex is going to be occurring at the midpoint, sorry, at the midpoint of the focus and the directrix, which I know is kind of confusing because the directrix is a straight up and down line. So another way of thinking about it is you could have from the focus, once you've drawn your general picture, you could have done like a pretend point, which isn't really a point. You could have done a pretend point over here, which would have been -2, 0. And you could have found the midpoint between -2 plus 2 and, I need to write this point or else my brain's going to start to melt. Let's see, what is this? -2, 2. And this one was 2, 2. So you can't find a midpoint unless you have 2 actual points. So I would think of like a pretend point over here directly across on the directrix. And I could find the midpoint between these two. And that's why I'm doing my little midpoint formula down here. If you needed a formula, like if you wanted a formula, for most people drawing the graph and then just finding the middle works generally well, but and then we have 2 plus 2 over 2. But we can return to that midpoint idea. That would be a mathematical way of finding it. And that would give us 0. 4 over 2 is 2. So let me go ahead and write some words to that. If you're ever in a case where it's dicey, where it's sticky to get to your actual vertex itself, we could say it's the midpoint of the focus with its corresponding point on the directrix. And if you're one of those that likes all the pictures, I'll be back to that in 1 second. The corresponding point would be the one directly in line with the focus, directly in line with the focus, directly in line with the focus, and the axis of symmetry. We could put it that way. It would be the intersection point between the axis of symmetry and the directrix is the other point that you would use, and you could always find the midpoint in between. So if you want a formula, that is a way to get it. Does that help?
Yeah.
So I guess I could have also drawn that axis of symmetry. And that's where I got that point.
You know, in the slide we have all the gradients, parabolas.
Yeah, I'll go back to that as soon as we finish this one.
I was just gonna ask, because it seems like the horizontal axis one, the equations are the same. Yeah.
They're the same, except here's the difference. P is a negative number or P is a positive number. So even though this one says H plus P, it's going to be H plus a positive number. And H minus a positive number. This one's going to be H plus a negative number, H minus a negative number. So it's going to look differently. So it is the same, except that P in one case is positive, which is going to make it look like that. In the other case, the P is negative, which is going to make the signs flip. Does that make sense?
Yeah.
Yeah, and I think it's the same thing for the vertical axis too. We have the positive P, negative P, which the formulas are the same. Like it works the same in that it's K plus P, but sometimes that's a positive and sometimes that's a negative. Jackson.
Is the distance from the directrix to the vertex always positive?
Distance, as like answering the question distance, yes, because distance is like absolute value. So it's a magnitude, like in vectors. But if we were talking about direction, then we would have to put on like negative or positive. I was thinking about like a Levison question.
No, I was just thinking like because it's like the directrix is on a -2, so like why wouldn't it be negative? Why is it still positive?
Well, if you told me that the directrix is -2 from the vertex, you're telling me how far to and what direction to the left. Does that make sense? So by giving me -2, you're giving me good information. Just one is the sign indicates direction, the number indicates distance. So when you asked distance, I answered yes, always think absolute value. But that doesn't mean that the negative doesn't have a meaning. Does that make sense?
Yeah.
So I know it gets a little tricky if we're not in like a specific application problem. But for those of you guys that are just trying to check your work and your final answer, y minus 2 squared equals 8x is completely appropriate as like a standard form of the conic that we're talking about here. But technically, if we were to talk about like the old standard form, you would have had x equals 1/8 y minus 2 squared. That's another way. Or if we want to be super, super snazzy and go back to that whole like, this equation encapsulates absolutely everything, lines and parabolas and conics and ellipses. Well, conics meaning hyperbolas and ellipses and circles. I could make it look like this. It would just be kind of disgusting. Because if I made it look like this, I would have to go all the way. And all the way would require things like, oh, I have to foil. And when I foil, I get stuff like this. And when I get stuff like this, I have to move it all to the same side. So here it could be another way of looking at it, but technically the highest degree term would go first. All of these are talking about the exact same thing, just in different ways. All three are talking about the exact same parabola, just in different ways. Ryan, you know.
Oh, sorry. No, my question was answered.
Oh, Johnny.
So you wouldn't be able to, like, if you did square y into 2 to get, like, y squared plus 4, you wouldn't subtract, like, you wouldn't do that. You would just keep it as y minus 2 squared. Like, you wouldn't simplify further.
Oh, for the getting x by itself. You could, I suppose. I didn't even think about that version. So I guess we could also say x is equal to, but in that case, careful, we would need to FOIL it all the way out. So you made the killing the puppy mistake. Because it's y squared minus 4y plus 4. Because it's minus 2y, another minus 2y, which makes minus 4y. But that would be, let's see, 1/8 y squared minus 4y times an eighth would be minus a half y plus 4 divided by 8 plus a half. Yeah, we could go to the old standard form as well. But yeah, it's like, ugh. But technically you're right. We could add another form too.
So we should probably just keep it at y minus 2 squared equals eta.
I think so. I think that's accurate, or that's appropriate for what WebAssign has. But that's one of the questions, or one of the reasons I would love for us to get into WebAssign for like 10 or 15 minutes and just have you guys check in, and so we can look at the answer key and make sure. Okay, so you would think we're totally done. We're actually not totally done. Because we already talked about yesterday, you guys were like, what's the whole, I don't get it. Why are there extra pieces? And we remembered last year in Algebra 2, how either Mr. Yu or I were talking about the microphone source and like a parabolic microphone on a sports field, or with like flashlights and reflecting and all that sort of stuff. But as far as like for calculus, there is one other, which Emily Ralph told me not to teach this year, but I'm going to at least show it to you. It was her least favorite thing in honors pre-cal. But it was also right before COVID, so I think that might have made a difference. Oh, I'm already zoomed in. I'm sorry, I was going to try and make it bigger. Let me do this instead. There is one application of what we're doing to calculus. In calc, tangents are really important, and we learn different ways of doing tangents that don't need geometry, but there is one type of function, a parabola, that we can actually do what calculus is required for every other function. We can actually answer this question for a parabola with geometry. We can't do that with anything else, except for a line, but a line is already a line. This idea of finding a trajectory or finding a tangent that skims something other than a circle, a parabola is the only other guy that we can use geometry for. And the way that we can do it all has to come back to the focus. Because the focus and the distance from the focus to any random point P on a parabola can be or can give us the exact same distance to get to another point on the axis. And those 2 points do form the tangent line. I know it doesn't seem very exciting for you. It's kind of exciting for me in the sense that I can show you a tangent line without showing you what calculus would call a derivative, without using a circle and without using a line that's really boring, but actually having something curved. But for you guys, I know it doesn't really mean much, but for you to understand, we can make this geometric figure, we can make this isosceles triangle where we have 2 congruent sides. So what would be impossible, finding a slope or a line that only touches the curve at 1 point, like we need 2 points for a line. We can't make a line with only 1 point. But for a parabola, if we figure out this point's distance to the focus, we can find that other arbitrary out there point that otherwise would be like impossible to find without much more advanced math techniques. With the focus, it's like, no, we can figure out that other point. We just have to say, hold on, quick detour, let's go to the focus, and then let's go ahead and come on down, and then we can have our x1, y1. We'll find our x2, y2, and from those we can make a good old-fashioned line from Algebra 1 where we say the tangent line can say y minus. Let's go ahead and take our x1, y1 from our p. So we can use that original point they gave us right away. The struggle is, the problem is, how do you find your slope? And that is exactly what half of Calc 1, otherwise known as Calc AB, seeks to answer. How do we find that slope if we don't know what that other point is because it's only hitting in one point? That's what trajectory is defined as. That's what a tangent is defined as. It's skimming in just one point. But for a parabola, we can say, no, we got this because we're just going to go find this other point using the detour of the focus. And then we'll go ahead and use our y2 minus y1 all for x2 minus x1. And we'll have our slope. And that might seem great and all, but then it's like, well, how do we actually do that? Well, we're going to find a distance between 2 points. And then we're going to say wherever the focus is, we're going to take away that distance and figure out what point we land in. And it kind of depends on the picture as to what that's going to look like. And I could give you a whole other like, hey, let's do 4 different pictures and 4 different orientations. Nah. It's not worth a whole other slide like this. So I'm just showing you the general idea, and then let's go try one problem, then we're done. Sound good? Just one problem, then we're done. We're at a tangent point. We're trying to find this other perfect point on this skimming line, but to find it, we do a quick detour to the focus. Here we go. Let's do one. If I was to graph the parabola, x squared, I'm going to kind of make it wide so we can see clearly what's going on. And if I was to graph the point 1, 1. And if I was to draw a tangent line. One of the easiest ways to draw a tangent line is to draw your parabola and just like take your pencil or your pen and say, what if I was to come up and hit it? Not go through it, but hit it. Like it's resting against. Okay? And then try to make that line. If I'm hitting it with my pen or pencil, what would that look like? Except me doing that from the side is probably not a good idea. Don't worry. You can judge my line all day long. I don't mind. Is that a little bit better?
Yeah.
Okay. Right away, on this line, I know one point, and his name is P. Otherwise known as 1, 1. But I need another point. I cannot make a line with just one point. I need 2. And so the other point I'm going to make is kind of like what we were talking about earlier, Ryan, with like the axis of symmetry and where it intersects the directrix. But this time I'm not intersecting a directrix. This time I'm intersecting a tangent line. And I'm saying, I want to figure out who you are. But do you remember what I said you had to do? In order to get to that other point, that magic point out in space, that magic point that would give us a trajectory. Anybody watch Hidden Figures? No? Oh, that's so sad. Such a good movie. The calculators at NASA that turned into like the superstars. Anyway. Never mind. I would allude to like one of the final scenes where she solves the problem. And it has to do with an old calculus method called Euler's method. They were trying to figure out how to bring the shuttle back into Earth's orbit, back into the atmosphere to return. They were having to figure out trajectories. Anyway. Go watch Hidden Figures. It's great. It's funny. It's factual for the most part. Yeah, I like that idea. Maybe over spring break. Let's not make it like before spring break because nobody has time before spring break. Okay, coming back. We want to find this magic point in space, but what did I say we have to do first? We have to take a what? Oh, I thought it was a good illusion. We have to take a... To go from here to here, we can't go from here to here. We have to take a...
Focus.
A what to the focus?
Tangent.
Tangent is this one.
Like a not actually tangent, but
Oh, we're going off on a tangent. That's actually pretty funny, but it's not the tangent. So I didn't use the word tangent. I used the word D, and I ended with tour.
Detour.
Detour. There we go.
You know, that's an anti-tangent.
I know. So instead of going off on a tangent, oh my goodness, Johnny just reminded us there's like an English meaning to this phrase, and you're supposed to be doing this, and then you go off into something else. That's what going off on a tangent means. Is like it connected at a point, and then it diverged. It went off into who knows where. Two roads diverged in a wood. That's something different. Okay, so we have point P trying to get to the magic other point on the tangent line. We have to take a tangent. No, take a detour. It's not mathematical. This is not a tangent line. We have to take a detour to the what? There was a lot of math in that little phrase. To the who is the focus? Oh, this is another part of homework that you guys might get stuck on. Hold on, we haven't had equations and had to find the focus. Well, is it?
We don't know. Vertex is 0, 0.
The vertex is 0, 0. And the only way that we can get to the focus is if we know P. Who's P? Oh, stink. Doesn't P come from this being written in standard form, and standard form says this? The x guy is the squared guy? Maybe it's good we did this problem for more reasons than one. Do you guys know how to find a focus if they don't give it to you? Yeah, exactly. So hold on, let's talk about this. So we have x squared is equal to y, right? To make it look like my standard form. So that means x minus 0 squared is equal to y minus 0. So question, who's in front? 1, right? It's an understood 1, but what do I need that to equal? Do you see it? So we make a little equation and we say, well, if we need p, then we know that, ooh, that doesn't work. 4p. 4p comes from 1. What does p equal? Oh, now you know how to find a focus. It's going to be 0 up 1/4. How many of you would have guessed that one?
How did we know that the coefficient was 1?
Understood.
Understood ones.
Oh, okay.
Understood ones. Because 4p comes from whatever this number is. And so the understood 1, if it came from 4 times something, well, 4 times what will give me 1? P must have been 1/4. So I'm just setting them equal to each other and saying, well, if you came from that, well, then I can solve for P by just, okay.
So you knew that the 4p was going to turn into 1
Mhm.
because of...
I was comparing it to that standard form, the new form where we find the P. You see it?
So the 1 was the understood 1 from...
Yeah, from the beginning. Mm-hmm.
Okay.
Mm-hmm. So then I have my 0, 1/4 as my focus. Do you guys want me to give you another equation? Just another, like, let's get away from the tangent line for a second?
On this.
What?
We should stay with
Okay, alright. I was trying to just get this idea down.
You need to expand their knowledge.
We don't want to make their minds explode, though. I'm just going to do it for a second. Just for a second. Calm themselves. So what if... We'll come back to this example. You don't need to write this down. Just hold on. What if? This is exactly like we were just doing. What if they give us an equation and they're asking for all the junk? Okay? Hold on. Before we get back to the tangent line, what if they're giving us an equation asking for all the junk? Okay? Why am I rewriting this as y minus 0 squared equals 3 times x minus 0? What am I trying to compare this to? Yeah, the other formula, the y minus k squared equals 4p. Andy, do you see what I'm doing? I'm just rewriting it to look like the guy I'm trying to find my information from. Does that make sense? In this one, it's not an understood 1. In this one, it's a clear 3.
Yeah, I see.
But first of all, hold on. The vertex is easy because the vertex says just take the h, take the k. That's just going to be 0, 0 in this one, right?
Yeah.
Okay. the focus, this is where some of you might go to that page with all the pictures and others of you might go to the picture itself. Question. Who's being squared?
The Y.
The y. If the y is being squared, is that normal?
No, it's on the side.
Ah, and is it going to be left or right if there's a positive number?
Right.
Mm-hmm.
That's what I'm talking about.
So I know wherever my vertex is, which I just figured out who he is, the focus needs to be going this way, right? And the directrix needs to be going this way. Are we tracking?
Yes.
Okay, so if that's the case, my brain thinks of it like this. I don't go looking at that page of all the pictures. I instead just figured out from like, okay, I know I'm going this way, the focus is that way, the directrix is this way. Check it. All I need is the distance p. So what am I going to do? Make a little baby equation and say?
Is that -3?
So p is equal to? Uh-huh. So what do I need to do? I need to go from my 0, 0 over 3/4. But my y doesn't change at all. And then for my x equals, I need to go back 3/4 from my vertex of 0, 0.
So how do you know it's gonna be positive?
Oh, I didn't know it had to be positive. I knew that the equation was positive, which meant I'm headed to the right.
Okay.
And the nice thing is, Ryan, like I naturally got p to be a positive just by making those two equal. If that was a negative number, I would have gotten p to be negative, which would have had me going the other direction.
So all you have to do is just like find the vertex and use P to find the directrix.
If you understand the movement of it like I do, or you go to that page with all the pictures and say, okay, which one works? And so for this one, our focus would be our final answer of 3/4, 0. And our directrix would be, Andy, does this kind of help with like what we just did in the problem before? Like how we can take an equation and work backwards?
Yeah, I think so.
So it's this whole idea of if I just make an equation look like a standard form, I can pull out information. And that's what I did here, is I made the equation look like the other form and I figured out what my P was to get my focus.
Yeah, because you had like only, you didn't have anything before, so you had to.
So the understood one was what my 4P needed to be. Yeah.
How do you know H and K equals 0?
Oh, because there's no addition or subtraction. So then it's an understood 0. But if I was to give you something like this,
Whoa.
it's not 0 anymore. But we'll get back to that in a second. We'll get back to that in a second. Okay. So then all we need to do, guys, is take our detour. To take our detour, we just need to figure out what's this distance, and then we'll just go down that distance. We have our point, and then we can know our line. So, distance formula. Let's go back to the very first day of class. Woohoo, it's been a while. I won't like go making right triangles and talking about changes in x's and changes in y's. We'll just plug into the formula. So the distance formula says x2 minus x1, so 1 minus 0 squared, plus y2 minus y1, 1 minus 1/4 squared. Have you learned this in honors pre-cal yet? To do 1 minus 1/4? Are we doing like common denominators yet? 4 over 4 minus 1/4. We'll end up with the square root of 1 plus 4/4 minus 1/4 is 3/4. 3/4 squared is 9/16, right? Have you gotten fractions down in honors pre-cal yet? Do you know that this would be 16/16?
Yes.
16/16 plus 9/16 is 25/16. Oh, and 25 square roots to be a 5, and 16 square roots to be a 4. Now we know our distance. And since this guy is congruent to that guy, because of the geometry of it all, my little detour says, you walked 5/4, cool, go straight 5/4 down, and what's 5/4 down from 0, 1/4? It's 0 and negative 4/4, everybody. What's 1/4 take away 5/4? 1/4 take away 5/4 is negative 4/4, aka negative 1. I just found my magic point in space that says, here I am, tangent line. Bum, 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 bum. So let me show you the math. We go ahead and take our focus minus our distance to go find our magic point in space, which would be 0, 1/4. Take away 5/4, which got us to 0, -4/4, which is the same thing as 0, -1. And from that, guys, we just have an algebra problem. I'm just going to make it green, because with this, it's like, haha, you have 2 points, and you just need to make a line. It's called point slope, everybody. And point slope says, go ahead and take the point that you knew from the beginning, which is y minus 1, equals x minus 1. All I need is the slope. And for slope, all I need is 2 points. Rise over run. y2 minus y1 all over x2. Which direction am I going? x2 minus x1. My slope is 2. Dun, 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 dun. Tangent line. Now, if I wanted this to anything else but a parabola, that would be so much harder. But a parabola has this special point of focus that can mean so many different things with microphones and reflections and receiving and transmitting signals of parabolic reflectors, etc. But it can also mean something for calculus and for physics with trajectories and tangents. If I take a detour to the focus, I can find a magic point in space that creates the trajectory line or the tangent line at any point on a parabola. Anyway, kind of cool for me, probably pretty boring for you guys, but let's get back to the things that you're going to need to face in homework. Oh, sorry, Barry. Go ahead. What's up?
The question for previous one. For that one, why the distance from focus point to point P is equals to the distance from P to the 0.
Oh, that's the geometry of what we showed back here. So that's the whole relationship that we're using. I don't know if I necessarily gave a reason why. It was more of just an understanding that this is what always happens with the parabola, and so we used that. It ultimately has to do with the angles being congruent. And because the angles are congruent, I have an isosceles triangle, which means the sides are congruent, but we didn't go very deep into the why. More the fact that, yeah, that is true. I'm trying to see if I see really quickly as to why. The proof might come back to calculus as to why that's true. No, I think this is geometry, though. I don't think it's calculus yet. Right. But then you could ask me, why are the 2 angles congruent? And I'm like, because they are. I'm sorry, that's not a good answer. But it's more of a geometric property that we used. We didn't prove. Yeah, good question though, Baron. Sorry that I didn't have a better answer for that. So let's end off with number 44, guys. This isn't a tangent line. This is just, hey, what are you going to do when you see? Because, Natalie, remember you were like, hey, why do I know it's 0, 0? And I'm like, because there's nothing there. But what's wrong with number 44? There's something there, right? Now, what if I was to organize things? Would you guys understand, why am I organizing things with the x squareds on this side and the 8y and stuff on that side? Why am I doing that? Any ideas?
Separate.
Yeah, what am I separating? The x's and the y's, and why am I keeping the squareds on the left? Like, that's abnormal. Don't we normally put the squareds on the right? I could add 9 to make it a quadratic, but for my standard form, what do I want over here on the left every single time? My squared. For the standard form with my focus and my directrix with that P guy, I want the squared on the left. So if I want the squared on the left, I'm actually going to keep this just as it is, and I would move the 9, except is 9 going to complete my square? I know. Is 9 going to complete my square? The answer is absolutely not, because if I think about this guy, I know not all of you think in this terms, but maybe enough of you do. I need this negative 2x to be evenly distributed, perfectly distributed to make a square, not a rectangle, which means I need a negative x here and a negative x there. I need to cut this in half so that the dimensions are the same. If the dimensions are the same, well guys, hold on, x times what would be a negative x? X times what would be a negative x? What would complete my square? And that's exactly what my little formula would say if you were in the business of formulas. Take 1/2 of the middle term, and then square it. You get the exact same thing, but this is more of a visual way of saying, take that middle term, split it up so you have even dimensions. To complete the square, you need a 1. What you add on one side, you add on the other side. And I end up with x minus 1 squared, because I made that nice and perfect, equals negative 8y minus 8. Oh, this is looking good. This is looking good, because can't I then go ahead and, I mean, even if it wasn't looking good, I still could, but I can factor out a nice little GCF. Woo! Can you pick out your information now? First of all, is this an up parabola or a down parabola if the x is squared? Sorry.
Sideways?
I meant, is it normal or is it abnormal?
Abnormal.
Excellent job saying down, but it's normal because the x is squared, right? If it's normal, why is it down? Why were they right?
Negative.
Because it's a negative, so it's going to be a down with the focus here and the directrix there, right? Worst comes to worst, you can go back and see your picture. If you have the x squared and a negative p, it's going to look just like this. My vertex, where is my vertex, everybody?
-1. Yeah, -1. What 1? Yeah.
Close.
One
X
negative.
minus, it's
Yeah,
1.
one
It's the opposite sign.
Oh, yeah.
I realized once looking at the picture.
I know, right? To get to my focus or to get to my directrix, I need a measurement. And what measurement do I need? I need P. And so to get P, I need to go ahead and spotlight exactly 4P is equal to. So therefore P is equal to, which would also indicate that I'm going down in that up-down orientation. The P is negative, so my focus is down. No, the directrix is going to be a y equals because it's horizontal, right? Which means I'm changing the y, I'm not changing the x. That's a nice little thing that goes together. One is a y equals, the other one affects the y. So I need to go down to, is down to taking away from the x or from the y, guys? Yeah. So going down 2 is going to be affecting the y, so I'm going to have -1 minus 2, aka -3. And then to get to the directrix, I'm going to go up 2, right?
Yeah, 1.
Ryan's doing despicable me back there. I was guessing your inspiration. I might have been wrong, but he's nodding, so I think I was right.
Oh, vector, yes.
If you need formulas, if you need formulas, the x was squared, the p was negative, so I went ahead and the -2, I plugged in k plus a -2, and I did k minus a -2. Like, there are the formulas. I found p to be -2, and I plugged in k plus a -2 is -1 minus 2. K minus a -2 is k plus 2, or -1 plus 2, and that's exactly how I got my answers. Maybe some of you are seeing how these pictures might be nice after all. Kind of just depends on your brain. I'm going to go ahead and leave this slide up. I'm going to give you guys 10 minutes. 10 minutes to get into WebAssign and see if you can have any questions that you want to ask me about how the answers are happening. Noah?
The
Yeah, go sign up. How the questions are being answered or asked, how the answers are being written, et cetera, et cetera. Let's just get a little bit of work done. I can go ahead and I'll put 12 minutes. I'll put 12 minutes on the clock. If you guys have any questions, just call me over. Sound good? That are online. So guys, quick homework help real fast on number 8. The question was brought, how do we do this one? So we're trying to get a standard form equation. You guys tell me, which standard form are we using? The one with an x squared or the one with a y squared? Yeah, because it's a normal one. So x minus h quantity squared equals 4py minus k. We know our hk, at least as indicated by the picture. Isn't that just 0, 0? But who's 3, 6?
Oh, point.
A point. So when I go to plug in x minus 0, what can I do with random points in my search or my quest to find unknown variables? Replace the x and y with the unknown point. Yeah. What else can I do? So I'm just going to take this for a second. I'm going to say, all right, well, what if x is 6? If x is 6, I have 6 squared is equal to 4p times when, oh, wait. Yeah, x is 3. My bad. My brain's just used to putting y on the left side, huh? 3 squared is x. And then 6 minus 0 is 6. So I would get p is equal to, what, 9 over 24? It should be the same thing as 3 over 8. And then I think at that point, Andy, you're good to go, because all you got to do is just get this 3 over 8 plugged back in, and then make everything look nice and neat as far as x squared equals 4 times 3/8 reduces. Let me get your final equation. And for those people that were joining online, a quick little heads up for something like number 12. I'm going to freeze the screen for the kids who are here in class, but we just had someone screen share their computer so we could look at number 12. Because you are going to have to graph your parabola. But to graph a parabola, you are going to have to use the vertex, which is a point. So we can click the little parabola. If we look at the y squared, see the negative, we know it's going left. We can click on that 0, 0, but you need another point, and the focus isn't on the parabola. It's in the parabola, so we can't use that one. So instead, we did some strategy where we were taking and plugging in different points, and what we ended up seeing was if we plug in something like x is equal to -2 and x that's over here where the parabola is, then I can go ahead and plug into my equation and get y squared, bless you, is equal to -2 times -2 just gave us an easy answer. -1 would have given us a nasty answer, but this one is a 4, and I know how to square root of 4, so then I can go ahead and get y is equal to technically plus or minus 2, but all you need to get your parabola is just one other point. So if you get up to that -2, +2 with that vertex, you'll totally have the parabola to make it check. All right, and here we are going to go start 10.3. So ellipses. The last 10 minutes of class. Let's just get the basics of ellipses down. What we would normally spend the first 10 minutes of class copying into our notes, we're just going to do that today so we don't have to worry about it on Thursday. Does that sound good? We'll get the main beginning step down, including the important picture. We're not going to do the visualization today, so you guys can kind of just leave that off if you want. That's not really something for our notes anyway. We do know that if we have an x squared and a y squared, well, let's make it even better. An x minus h squared and a y minus k squared. An x minus h squared and a y minus k squared. We know if those are being added, we should have a circle. But not everything that's rounded is necessarily a perfect circle. We have these shapes out there that are kind of like squash circles. Some people call them ovals. We're going to call them ellipses. Ellipsi? Nope, I don't think that's a thing. Ellipses. Not ellipses, that's in grammar. ellipse. An ellipse is kind of a circle, but it's been distorted a little bit. Anyway, once again, we're not going to talk about the visualization, not going to necessarily talk about the where it comes from today, besides just the idea of it's a squash circle. It has something to do with this equation that we've already seen. But unlike a parabola where its special geometry had to do with its focus, its singular focus from its vertex, ellipses are actually defined by the distances between each of their foci added together to any arbitrary point on the ellipse. If you were to take any arbitrary point on an ellipse and you were to figure out the distances from one focus and the other focus and add them together, it would always be the same number. Always, 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 which is pretty cool if I start putting magnets and string and a marker. But we're not going to do that today. So even though it's defined by this, and even though I can kind of make an ellipse if I had like a marker and some string and some magnets, even though my magnets keep on going missing. All my bad ones are the ones that are left. And I can show you where an ellipse comes from. Mathematically, that's all we're doing today. Mathematically, how can I make what's perfectly round be a little bit squashed? And this is it. How can I take what's perfectly round, wow, you guys are easy to please today, and make it a little bit squashed? I just say I'm going to kind of play with the dilations. I'm going to kind of play with the x terms and the y terms, and I play with them by dividing. Technically, you can think of multiplying by a reciprocal. You can think of that, but you can also just think of dividing. It's the easier way. And let me label a few things, okay? Once again, getting down the main formulas today. If you notice, the r squared has disappeared. Hasn't really disappeared, it's actually been divided to the other side. If I was to take, I know, I'm going to stress some of you out. Just take a breath, pick up your pencil, you're fine, breathe. Sometimes when you're feeling anxious, you just need to pause and breathe. Remember yesterday's sermon, pray at the same time. Okay, if I was to divide r squared to the other side, I get a 1. A perfect circle says, hey, I'm the same for everybody. A perfect circle says, hey, I'm the same for everybody. An ellipse says, what if it's not the same? Oh, okay. What if it's not the same? The cool thing is what I can say is r squared, the radius, if it's underneath the x, that's going to be what we call the x radius. And if it's underneath the y, it's going to be what we call the y radius. Maybe a better way of saying that is the horizontal radius and the vertical radius. So they do still kind of maintain their radius meanings, but instead of being like a radius around the entire shape, it's like, no. I'm half the distance if you just cut it horizontally. That's A. Or I'm half the distance if you cut it vertically. That's B. Well, okay. I think it's a little bit awkward because A is always... He has like a complex. He always has to be the bigger one. He always has to be like the tougher one. He always has to be, okay, so if my orientation switches, A is just saying I go with the bigger one, I'm the major. B says, okay, that's fine, I'll take the background. I'll be a supporting role. I'll be the minor. But the really nice thing is I can just look at whatever it's under and say, okay, so A, you're under the X or whatever. You're under the X, cool, you're going horizontally. Whoever's under the X, okay, cool, you're going horizontally. Whoever's under the Y, you're going vertically. Now careful, it's a square root. It's a square root, just like we would have to square root the r squared to get the r. But even though A and B can kind of change names, because A just says, I'm the major one, I'm the main one, I always have to be the top dog. If I want to be specific, I would say he's the major radius. So he just goes with whatever's bigger, whatever's the larger number. If you want to be super specific about naming things. And B is the minor. He goes with whoever's supporting. The smaller of the two. Even though their names switch, the nice thing is that still whoever's under X is always horizontal and whoever's under Y is always vertical. And then otherwise, all I need to worry about is that whole little HK guy, but guys, nothing changed. HK is still, hold on. It was the vertex of the parabola, but what is HK for a circle? In a circle, what's the HK? The center. The center. Yeah, it's different for an ellipse or for a circle. There is no, well, I shouldn't say there is no, but HK denotes the center of it. So that's a little bit different. It's not on the ellipse itself, it's the center, it's the HK. Yeah. Yeah, you can think of it that way. And then we do technically have vertices. They're just on the ends of them. On the edges or on the ends of whatever is major, whether it's horizontal or whether it's vertical. So in this one, I would have my H plus A, K. If they ask me, it's not that I love talking about these guys, but if I ever need to find them, I can. But for this one, it would be my H, K plus A. And H, K minus A. If you guys notice, these sections are going to feel really similar, except the formulas change a little bit to denote or to show or to signify. To express different conic sections. We did parabolas first, ellipses second. Circles are kind of in here too. Hyperbolas will be next, and then we're pretty much done with the chapter 10. At least with the part that we're going to be doing this year. But we just need to figure out how to use it. So go ahead and finish up your parabola homework tonight. / tomorrow, come into Math Lab if you need help, reaching out, etc. And then ellipses, I mean, as you build your skill with parabolas, you're going to be able to use it with ellipses, just the formulas change, okay? Bye guys, I'll see you later.